Hi, my name is Dan Hemme. I'm from Austin, Texas, and I'm a student at the ME Graduate Acoustics program at UT Austin. My master's thesis involves the characterization of sound power level spectra generated by HVAC chillers with double helical rotary screw compressors. These are more commonly known as screw chillers. I gathered data for this project by visiting 11 local air and water-cooled screw chiller installations. My research assistant, Zane Rusk, and I measured sound pressure levels in situ, and then I calculated sound power levels according to the two-surface method. The same chiller units were visited in the spring and again in the summer, so the data from most of the units are available for at least 2 operating conditions. A total of 20 operating conditions were measured. The sound power level data is being analyzed for each unit under different operating conditions, and also for all air-cooled and all water-cooled units as groups. Manufacturer-provided data is also being compared when it is available. The end goal of this line of research is to develop equations that can be used to predict the likely 1/3 octave band sound power level spectra generated by screw chillers that are being considered for an HVAC design. This type of equation already exists for many other types of mechanical and industrial equipment. Many of the existing equations were developed by Lehman Miller, who, by the way, shares a birthday with me and also attended UT Austin. Mr. Miller was an acoustical consultant working for BBN when he developed this family of equations along with a noise control course geared towards end users in industry with perhaps limited acoustical background that he offered on an annual basis. Lehman Miller retired in 1981, about a decade before screw chillers came into vogue. Although the family of equations that he developed is still used by acousticians, and the noise control course that he founded continues to be offered, there has been no further work towards developing a similar equation for screw chillers. The goal of this project is to take the first steps to developing such equations for air-cooled and water-cooled screw chillers. In contrast to Lehman Miller's equations, which produce octave band level spectra, I am working on equations for 1/3 octave band level spectra in order to reflect the prominent narrow band components that are typical of screw compressors. To find out more about research being done within the acoustics program at UT Austin, visit the Texas Acoustics website. Thanks for watching.